In this video, we're going to review from last year some basic ideas behind the motion problem. Okay, so quick review of the types of things that we're going to be looking at. First thing is some notation. So last year you would have learned that generally if we want to represent the position of some object, we use S of t. And that represents the position function. Sometimes you'll see little x of t as well, but a lot of times we'll just use S of t. Now, if we want the rate of change of position, in this case the instantaneous rate of change of position, which is a derivative, when you're looking at a rate of change of something's position, you're looking at the velocity. So we're going to label that as v of t. And if we look at the rate of change of velocity, specifically the instantaneous rate of change of velocity, we're looking at the derivative of velocity, and that's going to give us acceleration. And we're going to label that as a of t. Okay, so we're going to talk more in class about, why that is. Right now we're just kind of accepting it as true, but we'll do a lot of problems where we're dealing with averages and instantaneous rates of changes, and you'll see how one is the derivative and the other one is just the slope function. Okay, so anyhow, the problem that we have in front of us, we have a coin which has been tossed from a bridge that's 48 feet above the water, and the position function is given to us. So the position for our coin is negative 16t squared plus 32t plus 48. And S is measured in feet, t is measured in seconds. We also are told that our time values, we're going to go ahead and just assume that time is positive. So it's going to be greater than or equal to 0. Because it says up here at the beginning, time t equal to 0 is when we tossed it from the bridge. Okay, so that's when we started keeping track of the position. Okay, so question A says question A says, when does the coin hit the water? Okay, so when does it hit the water? Well, it's going to hit the water when the position is equal to 0. Okay, so if we want to know when the position is equal to 0, that means we just need to take our function for position and set it equal to 0. So we're going to set S of t equal to 0. And then we're going to solve for t. So what time did the position equal 0? Okay, so doing that, we're going to take our position function of negative 16t squared plus 32t plus 48, and we're going to set that equal to 0. And we need to find what values of t. Okay, so we can go ahead and factor this out. Pull out a common factor. That'll leave us with t squared minus 2t minus 3. And then when we factor the rest of this out, we end up with t minus 3 and t plus 1. Okay, so now solving for t, we get that t is equal to 3 or it's equal to negative 1. Okay, but we said that t had to be greater than or equal to 0. So that means the only one in this case that we care about is t equal to 3. So we're going to eliminate the negative 1. It doesn't make any sense in this case. Okay, so our conclusion, when t equals 3 seconds, or after 3 seconds, the coin hits the water. Okay, so there's part A. All right, so let's look at part B. Part B wants to know what is the coin's velocity at impact? Okay, well, in order to figure that out, we're going to need to know what is the velocity function first. So we need velocity function. Once we get the velocity function, then we can find out what is the velocity at the time in question. And here the time in question is 3 seconds. So we need the velocity function, and then we need to find v when t is equal to 3. So let's do that. To get the velocity function, we need to take the derivative of position. So the derivative of our position function is going to be negative 32t plus 32. So from this velocity function, we're going to be able to tell what's the velocity at any moment in time. So this is our velocity function. But the value that we care about is v at 3. So we plug in 3 into our velocity function. And here we get negative 64. And our units in this case, well, what are we looking at? We're looking at a rate of change of position. Position was measured in feet. Our time units were in seconds. So this would be 64 feet per second. Okay, so we can write that up in our conclusion. At impact, the velocity of the coin was 64 minus 64 feet per second. And if you remember from your previous coursework, the negative sign just tells you what direction, right? Velocity gives you both how fast and in what direction. So the direction says that the negative just means that the coin was falling. Okay, so that's just kind of a quick review of what you have learned previously about position, whether it was in physics or in pre-calc last year. And when we come back to class, we will discuss some other more advanced problems. And we'll see you then.